Hey guys, here we go. Tonight we're going to talk about 12 basic functions, and you must memorize what these are because what we're going to be doing in the next couple of days and weeks is we're going to be doing transformations, and we're going to be flipping these things and rotating, reflecting, and squishing them down, stretching them out. And so what you have to do is memorize these things. So we're actually in your textbook. It's page 106 if you want to look along. And we're going to start, just jump right in. So the first one we're going to talk about is called the identity function. All right, and they're all functions, so after this I'm not going to be writing the word function. So the first one's called identity function, and actually we go linear. It's a linear function. And so it's f of x equals x, or you might be more familiar with y equals x. And so if you want, we can just plot this along, and you can just with a calculator without. So it would be 0, 0, 1, 1, 2, 2. So it's going to be a line going like this. Right, -1, -1. Now you'll have real graph paper, so yours will look much better. And you can just punch it in your calculator if you wish. The next one we're going to talk about is they call it the squaring function. And it's just sometimes you'll hear it called squared. And this is just f of x equals x squared. And what you need to know is this is called the quadratic. So the squaring function, you might have heard it called quadratic. It's something you probably heard. The squaring function is going to be x squared. And so if we look at a calculator, we just make a table, right? So like I can make a table, and so I can punch in x, and this would be my y's or my f of x. And right now I go 0, 0, 1, 1, 2. 4, 3, 9, because I'm squaring these things. So that would be 0, 0, 1, 1. So 1, 1, 2, 4, right? 3, 9. Up here, right? And so it's going to be something like this. And we go the other way, and it's, roughly, it's going to look like this. It's a parabola, right? The graph is called a parabola. Okay, I apologize for the pen. I'm using the school smartboard. And so you get these other ones by going the negative side, right? So -1, positive, right? It's because it's an even function, and so it's going to spit out positives. All right. So let's try another one or another couple. So we'll do cubing, the cubing function, and you have to not only know the names, you got to know the equations, you got to know the shape. So the cubing function is it's a cube, right? So it's f of x equals x cubed, and that's an odd function, and we talked about this already. Odd functions, one will point up, one side points down, but I can also go like this. So it would be 0, 0, 1, 1, 2, 8, 3, 27. So it's going to go something like this, and then it's going to swing back around, go the other way, something like this, and it continues on. Now, all the stuff that we've been talking about in the past for the last couple of days, like this is an odd function because it's an odd exponent. It's reflected through the origin. All that stuff is still legit. It's all still counts. We could talk about domains and range and all this other stuff. Increase, decrease, all this stuff we can still do with these functions. All right. So this next one we'll talk about is called the reciprocal function. And this is going to be f of x equals 1 over x. Now, last year we called these, it was called a hyperbola, inverse variation hyperbola. But now it's going to be called, we'll call it reciprocal function. So the graph itself is called a hyperbola. The function is a reciprocal function. And we can look at some, some. It's going to be this general shape. Now, there's no scales marked, so I can get away with doing this. But like, like if x is, technically if x is 1, it should be 1. I'm just going to put it in here like this, okay? Right? Because there's no scales marked. It's just a bunch of little dashes. All right, but that's the general shape. Another one we got here is called the square root function. All right, and that's radical x. So f of x is rad x. And so it starts at the origin, right? So, and square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and it's this hook shape. Okay, it actually keeps on going, right? It doesn't flatten out, but it grows. It goes really far in x before it goes up in the y. What else we can do? Notice the domain doesn't go negatives, right? We talked about this. We don't have imaginaries in there. We got exponential functions. Oopsies. And exponential function is, now, you might have memories of e to the x from trig. Hopefully they're not too bad. E is an irrational number. The number E is an irrational number. It's like pi, okay? So it's like a transcendental. It keeps on going forever. So let's see what E would look like. Now, so E, now if I put E, x is 0, so E would have to be 1. E is about like 2.7 change, whatever it is. So, so like at 2, I'm at like 5. So it goes like this, and then it goes this way, right? And so, right? And all that stuff we talked, like, so it's asymptotic to the x-axis, it's increasing, all this other stuff, the domain and the range and all that thing, everything is still fair game. Natural log function. Okay, so that's actually the inverse of the e to the x. So this would be f of x equals ln of x. We'll do a lot with natural logs, and we do a lot with it when we hit the calculus, when we start calculus too. So it's going to go, so the inverse, it was before, it was 0, 1, so this would be 1, 0. And it's going to head this way instead, like this, and it goes something like this. Okay. We're going to talk about sine function. So this is f of x equals sine of x. And so, if I'm doing this in radians, let's say, it's just going to go something like this. It's about 3-ish. So 1, so about 3, 3, 3, something like this, right? And it keeps on going forever. It just keeps repeating. This is bounded, right? We talked about bounded. So all that stuff is good. Something like this, and it goes forever. So this is f of x is sine of x. We're going to talk about, let's see what else we got here. We got the cosine function. Right, so f of x equals cosine x. Okay, and that was the, right, so let me change my scale here a little bit. Whatever. So we'll start at 0, so 0, 1, and then it comes back here like this. Actually, that would be down here. And up at 3 again, something like this. It's going, keeps on going both ways, right? So 3, something. Right, so I can get away with this a little because I don't have a scale. In class, we will definitely be using like scales and being really careful. We're going to do absolute value. Okay, so f of x equals the absolute value of x. So 0, 0, 1, 1, 2, 2. Right, so it's a V shape, and that's right. Kind of bounces off. It's a V. All right, so those you've seen. All right, the newest ones called greatest integer. All right, the greatest integer function. Now, let me fix this. I need some more room for this one, so I want you to really see this one. So this is called the greatest integer function. Now, you've been doing greatest integer function your whole life. Nobody ever told you though. All right. So the greatest integer function will be like this. So it's going to be closed, right? And then I go to 1, and it's open at the 1. Okay. And then once you hit 1, it jumps to the next closed and open. All right, so the greatest integer function, the way we write it, is f of x equals int x. And there's other notation we'll talk about in class. So a lot of times this will be called a step function. Okay, and so like you've been doing your whole life as a step function, nobody ever told you, right? And so for instance, like, right, let's say like you start like whatever, you know, you're born and you keep on going, but until you hit 1 year old, you jump to 1, and then you're 1 year old every day until you hit 2, and then you jump to 2. Or you're what do you call it? You're a 9th grader. You're a freshman, jump next year. You know, sophomore, jump, senior, junior, jump, senior. So this is a step function, and it goes the other way too. You know, you can go backwards like this. All right. So -1, right? And you just kind of go. So this is a step function. And then finally, what we're going to talk about, I should recolor it in. The last one, which is we're going to do some good work with, is called the logistic function. Okay. All right. So now the logistic function goes like this: 1/1 plus e to the -x. All right, this is the one we're going to need practice, right? You know how to do an absolute value. You know, you've done sines and we're going to review it, but you've done those things. That's not the issue. This one is the crazy one. This has 2 horizontal asymptotes. Okay, so there's one here and there's one on the x. And so right here, so this is at 1, okay? And this is in the middle. And it goes like this. So I'm going to change colors here. So you can see this. Okay, it goes like this. It's kind of like a slanted S. Okay, and it goes like this. All right. We do this a lot, especially if you're going on to biology or business and stuff. We're going to do logistic function modeling. And that's our logistic function. So that's the 12 functions you need to know the general shapes and the equations. All right. Thank you very much. Have a nice night.